design steps that are required for the detailed design of a precast concrete box culvert can vary by application, or can also potentially vary by the code that is being used for the design of the units. However, there are certain fundamental standard steps that would be applicable to the vast majority of culvert designs. The first step, of course, is to define the loads that are applied to the culvert, which we've discussed in previous discussions for culverts. That load will result in load effects, bending moment and shear, principally we're interested in. Those load effects we would quantify, typically using an analytical model. And generally we would use a very simple two-dimensional analytical model wherein we're just examining a 1 meter strip of the culvert. So we're ignoring transverse distribution of that bending moment, that shear, those load effects. Once you've set up your model, applied the loads to it, and you've pulled out those load effects, that bending moment and shear, we'll then move on to the design of the reinforcement and also the required thickness of your culvert. So the design of the reinforcement and the requisite thickness of your box culvert slabs and walls is typically governed by the ultimate limit state bending moment design checks. Essentially what we're doing there is we are using reinforcement, specifying the size and spacing of the reinforcing steel that is required to give us a moment capacity that exceeds the applied moment. And again, for box culverts, we actually need to do that at multiple points. We'll need to do it at the midspan of the slab. We need to do it as we get near the end of the slab. We need to do the top of the wall, the midspan of the wall, so on, etc. There are multiple points that need to be examined for bending moment. Indeed, for all of the load effects that we're considering. We would also need to carry out a serviceability check on crack width for bending moment as well. So that is fundamental. We now would need to carry out calculations, which can be a bit messy, a bit complex, in order to calculate what is the expected design crack widths that would develop as a result of the serviceability factored bending moments. Those crack widths must be within a certain limit. We would also examine shear design as well too. The shear that we would pull out of that analytical model, that shear force will also need to be accommodated by the section thickness and by the reinforcement, the longitudinal reinforcement we're putting into the slabs and into the walls. There are situations where there is significant benefit in actually using shear links. Many people have got accustomed to the idea that links would never be used in a box culvert. They're too much trouble, and they're not popular with the seal fixers, of course, but there are situations where it is justified to use shear links in a box culvert over specific lengths of the slab and sometimes the wall. You would also need to carry out minimum reinforcement design checks as well too, and those will depend which code you're using. Codes clearly lay out the minimum reinforcement requirements. Those would need to be satisfied, and quite often those minimum requirements will govern what is required for steel reinforcement that passes transversely through the walls and slab of the culvert. Those are the fundamental, essential steps to the design of a box culvert. There are other ones that may be required or brought in depending upon the requirements of the relevant code, but those design steps would be essential and applicable to effectively all box culvert designs.